With the question 2 completed, let's proceed to question 3. Determine the CBR value for the material tested. For laboratory CBR, we conduct the test on both sides of the sample, ending up with two sets of data for top and bottom surface. In this question, the data plotted is only for 1 mole of CBR. Remember, for the real laboratory CBR determination, we need to compact 3 moles of sample at optimum moisture content with different compactive effort to get the CBR at 95% compaction. Now, let's try to determine the CBR value for the bottom surface of the material for this question. First, draw a smooth line to connect all the points of the bottom layer. After draw the line, let us look back at the procedure to determine the CBR value. First, check whether correction is required for the CBR curve or not. Next, determine the load at 2.5 mm and 5 mm penetration for the curve. Then, compute the CBR value by dividing the load with standard load of 13.24 kN at penetration 2.5 mm and 19.96 kN at penetration 5 mm. Lastly, select the larger value of the curve as the CBR value. Back to our graph, this CBR curve is similarly with CBR curve in question 2. It is a concave curve, so there is no need to do correction. So now, we can proceed to determine the load at 2.5 mm and 5 mm penetration from the curve. Draw a vertical line from 2.5 mm and 5 mm penetration and determine the load from the curve respectively. For the bottom layer, the load at 2.5 mm and 5 mm penetration from the curve is 14.5 and 24.2 kN respectively. Now, the load at 2.5 mm and 5 mm penetration are determined. Proceed to compute CBR value by dividing the load with the standard load and select the larger value as the bottom CBR value. As you can see, the CBR value for the bottom layer at 2.5 mm and 5 mm is 110% and 121%. So, the CBR value for the bottom layer is 121%. After we determine the CBR value for the bottom layer, let's try to determine the CBR value for the top layer. As the bottom layer, first draw a smooth line to connect all the points of the top layer. Again, let us look back at the procedures to determine the CBR value. First, check whether correction is required for the CBR curve or not. Then, compute the CBR value by dividing the load with standard load of 13.24 kN at penetration 2.5 mm and 19.96 kN at penetration 5 mm. Lastly, select the larger value from the curve as the CBR value. Back to our graph, since the CBR curve of the top layer is a combination of concave and convex curves, so we have to do a correction for the curve. The correction is done by drawing a tangent line to both curves as seen in the video. The point of intersect of the tangent line and x-axis will be the new origin for the curve. For this curve, the new origin for the curve is 0.49 mm penetration. Now, determine the load at 2.5 mm and 5 mm penetration from the new origin, which is located at 2.99 mm and 5.49 mm respectively. Draw vertical lines from the 2.99 mm and 5.49 mm penetration and determine the load from the curve respectively. Therefore, the loads are 9.2 kN and 18 kN at 2.99 mm and 5.49 mm penetration respectively. After that, proceed to compute CBR value by dividing the load with standard load and choose the larger value from the curve as the CBR value. As you can see from the video, the CBR value for the top layer is 70% and 90%. So, the CBR value for the top layer is 90%. Now, we completely answered this question. However, in real laboratory CBR determination, we will proceed with two other moles to determine their respective CBR values for top and bottom. Move to the last question. The question required us to plot the dry density versus moisture content graph, the soak CBR versus dry density graph, and also to determine the maximum dry density, optimum moisture content, and CBR value at 95% of maximum dry density. Let's try to fill up the table first. It can be seen in this video that the dry density value are missing from the table. The formula used to determine the dry density values are shown in the sample calculation below the table. When moisture content is 2.34% and bulk density is 2.151 megagram per cubic meter, therefore the dry density is 2.102 megagram per cubic meter. Now, try to calculate and fill up the rest of the table using the formula given. This is the completed table for question 4. Please check and ensure that your answers are correct and do correction if necessary. After all the tables have been completely filled up, let's plot the graph. First, let's try to plot the dry density versus moisture content graph. Similar to question 1, the moisture content will be at the x-axis and the dry density is at the y-axis. Now, plot the graph based on the value in the table. Draw a line to connect all the points. Again, please remember that the line connecting the points has to be a smooth and not straight line. The optimum moisture content and maximum dry density can be obtained from the graph. As explained previously, the optimum moisture content and maximum dry density are the value at the peak of the curve. For this question, the optimum moisture content is 6.6% and maximum dry density is 2.198 megagram per cubic meter. Next, let's proceed to plot the soak CBR versus dry density graph. For this graph, plot the axis of the graph with dry density as the x-axis and CBR value as the y-axis. Then, plot the points for both layers on the graph based on the value in the table. Then, draw a smooth line to connect the point for both layers respectively. After the graph has been plotted, let's determine the CBR value at 95% of maximum dry density. First, determine the value of 95% of maximum dry density. As you can see, the value of 95% of maximum dry density is 2.088 megagram per cubic meter. Next, proceed to determine the CBR value at 95% of maximum dry density for both layers. Draw a vertical line at the value of 95% of maximum dry density and determine the CBR value for each layer respectively. For this question, the CBR value for the top and bottom layer are 72 and 91% respectively. Final step is to determine the average value of CBR at 95% of maximum dry density from both layers. As you can see, the CBR value at 95% of MDD is 82%. With this, we have completed all the exercises on compaction and CBR. That's all from me. I hope that this video is able to provide you a better understanding about the CBR and its related calculation. Thank you for watching.